Here in the introduction part, just you are learning about what you understood or what you are thinking, how they are getting that what they required from the shop, right? So they are following in arrangements a particular what classification basis. So without basis, you are not arranging them. Without basis, you are not arranging them. So here, that same thing are we able to follow in our classification? So in the classification of elements, is it possible to you? Yes, possible, right? So here we have many elements, right? Many elements. So here in these elements also, they are maybe with the similar properties or maybe with the same behavior towards chemical reactions. Physically or chemically, they are maybe similar or completely different, opposite behaviors, right? So everything about its state. So everything are you able to know without classification about the element? Is it possible to you? Not possible, right? So that is the importance of classification of elements. So explain it with the help of that general store or medical store, whatever it may be, super bazaar, or using your bag, how you are arranging everything. So anything you can use. So each and every point we covered related to this basic concept, right? So scientist names, everything. Okay, the next look at here what is given in the next page. So here simply what is element we discussed it. Totally available elements, right? So here who just try to give importance for the classification, given importance for the classification, right? So the basis is suggested here. They are actually tried before, but they don't know what is the basis for the classification. They thought differently, physical properties or the chemical properties. So here, based on the both, they are trying to classify the elements, right? So here, simply what here sodium, potassium, magnesium, calcium, aluminum. These are what we learned them as here. Actually, they are highly reactive elements. So it is based on the chemical property. Suppose if you take gases O2, Cl2, N2, H2, likewise, are the same as your sodium, potassium, calcium? No, right? So here simply their physical appearance or physical properties are different, right? So here they are searched different solutions, how to classify them, which is the easy manner, which helps us to understand about complete physical and chemical properties, right? So simply we are now going for the classification of elements based on the physical and chemical properties. Physical and chemical properties. So how to decide that? What are the physical properties? What are the chemical properties? So they started, right? Then everything they found, right? Physical properties, chemical properties, how to realize them, everything they got solution. So they started one after the other. Now we have everything, but at the time of Robert Boyle, they don't know. At least elements also not discovered. Elements are also not discovered, introduced. So based on them, They are started thinking, which is helps us. So first of all, we are discussing about Doberan's law of triads. Doberan's law of triads. So he tried to classify elements first, right? So that is given as triad. That is given as triad. So what is actually a triad? What is actually a triad? So that is given by Doberan as here. Triad means simply a group of three elements. Triad means what? A group of three elements. Sir, every three elements is considered to be a triad? No. Right? That group of three elements also based on a characteristic property. Simply, suppose here you have elements, sodium, potassium, right? Sulfur, chlorine. All these elements will be classified into a group of three elements. Suppose I'll take sodium, potassium, and sulfur. Can we take these three as triad? No. Group of three elements are given as triads, but condition is applied for that is simply here basis, we can call that here based on the property of the element is taken as its atomic weight. It's a atomic weight. So that atomic weight of the elements is considered as the basis for the classification of elements. So here that atomic weights are arranged in a increasing order. In the order of increasing of atomic weights. When they arrange that available elements at the time of Doberan, right? At the time of Doberan, what the elements are available, that elements are arranged in the increasing order of atomic weights. Then he observed what? That the physical and chemical properties are repeating. So here that he observed, and then he tried to classify the elements on the basis of that atomic weight. On the basis of the atomic weight. So simply what he tried to say that elements, physical and chemical properties are the periodic functions. Periodic functions. Periodic means repeated. Right? So that can be repeated, reobserved with the different elements. That property reobserved with the different elements, not with the same elements. Right? So based on that observation, he made a group of three elements. Right? Basis for this classification is atomic weight. What atomic weight? Increasing order. That atomic weight in the increasing order. So based on the increasing order of atomic weights, he tried to give a relation between the elements, right, which are repeating in the triads or simply in the same order, right? Similar. They are observed as similar in their characteristic properties like physical and chemical properties. That he tried. So that elements in the same group of three elements, that are named as a triad. So simply triad is a group of three elements and which can satisfy one of the rule given by Doberan. That is what here sum of the atomic weights by number of observations. What they are here? First and last, especially in the group or in the triad, atomic weight of a first element and a third element average. First element and the third element average is equal to the middle element is equal to the middle element. So here, how they are selected into that in the increasing order of atomic weights. So in the increasing order of atomic weights of a group of elements called a triad. So in the triad, suppose something X, Y, Z, three elements are there. Their atomic weights you need to find out. So they don't know the method of finding. They are simply based on the what group of sorry, not group of that nucleons and protons, right? Given as atomic mass number, as whole numbers, they started to assign a value for the elements as their atomic weight. So that whole numbers are assumed by the neutrons and protons. They don't know exactly that count of neutrons and protons, but sorry, only the protons count they know, but they don't know neutrons count. Later on, they discovered how to find out number of neutrons present or situated in the nucleus. Then they are able to predict that mass of the electron, mass of the proton, and mass of the neutron. Right? Then, based on them, they are trying to give a relationship. So simply, they are arranged only Dauber-Inner. They are elements are arranged by Dauber-Inner in the increasing order. In the increasing order of atomic weights. Increasing order of atomic weight. So atomic weights are used. They are arranged in the increasing order. Suppose let me take as X, Y, Z. That three elements were selected into the group based on the increasing order of atomic weights, and which can satisfy the atomic weight of the first element and last element average. That means A plus B by 2 will give you something value C. That C is the atomic weight of the middle element. So these three elements are called as here triad. Have you got meaning for the triad? Which is triad here? It is a group of three elements. It is a group of three elements. That three elements are arranged in the increasing order of atomic weight, and the middle element atomic weight is the average of first and last. So that is given by Dauber-Inner. So this is only called as Dauber-Inner's law of triads. What he observed and what he tried to make a group of three elements, that based on the observations, that is taken as here law. So that he tried to apply for all elements. But at the time of Dauber-Inner, they don't know all the elements. Right? Atomic weights, they don't know actually. Right? So before going that, I'll show you that examples for Dauber-Inner's law of triads. Dauber-Inner law of triads. So simply here we'll go for another here. So in this, I'm giving you the examples for Dauber-Inner triads. Right? So what are examples for Dauber-Inner triads? So for that, I'm taking a group of three elements and elements and their atomic weights. Elements and their atomic weights. Finally, what is the average of atomic weights of first and last? So first example for the Dauber-Inner law of triads or group of triads, right? So that is something A, unknown group name. Here lithium atomic weight is 7, sodium atomic weight is 23, and potassium atomic weight is 39. So what is Dauber-Inner law of triads? It says first and last atomic weight average must be equal to the middle element. So we will calculate 7 plus 39 by 2. That will give you 46 by 2. So 46 by 2 will be give you 23. So that 23 is the atomic weight of sodium. Okay. So this we can take it as example for the triad, Doberanus triad. So second example we will go for. Right? What is that second example? Calcium, strontium, and barium with atomic weights respectively 40, 88, and 137. So here, if you take the average of first and last element, that means 40 plus 137 by 2. That equal to what you will get? 137 plus 40. It is giving you 177. 177. So here 7, 3 and a half plus 170 half is 85. 88.5. This is about a second triad. Third triad. That is what? Chlorine, bromine, and iodine. So what is the average you can take here? Whose average is required? Can anybody? Whose average we are calculating in the triad? Which elements? All the three available elements? No, only the two elements from the triad. What they are here? First and last element. So 35.5 plus 127. It is giving you 162.5. 162.5 divided by 2. So what you are getting here? It is giving you 81.25. 81.25. That is the average. Then one more example for a triad. What is that? Sulfur, selenium, and tellurium. Sulfur, selenium, and tellurium. Then what is the average? 32 plus 125. It is 157 by 2. 150 half 75. Then 7 half 3.5. So you will get 78.5 is the average. The next, one more example, that is manganese, chromium, and iron with the atomic weights 55, 52, and 56. Then what is the average? It is 55.5. Average is 55.5. So now observe and answer. What is the law of triad says? What Dauber given? Law of triads. It is the average of first and the last element. Here, how many triads are satisfying the law of triads here? Can you find them from these 5 examples? I gave you 5 examples for the Dauber triads. Are you able to see the law in this average? Not same. Look at here. First one, 23 is the average of first and last element. So that is only we have exactly as atomic weight of sodium. Okay, there is no problem. Then look at the second one. 0.04, sorry, 0.5 is different. Strontium atomic weight is 88, but here by the average, what I got 88.5. Selenium 78 is the average. So 78 is the original atomic weight, but average 78.5. Suppose look at another one. Chlorine, bromine, iodine. What the average you got? 81.25. But originally, atomic weight of bromine is showing the law given by Dauber. Is it satisfying? Is it exactly standing for the average value? No. Average value, what we are calculating by the first and last element, will not be standing for the practical value, experimental value. So, is it taken to be a successful classification? Shall we consider this? No, we cannot consider because failures are there. Because failures are there in the Dauber-Inner law of triads. Dauber-Inner law of triads. So this is about triads. Then what are the limitations we can explain for Dauber-Inner law of triads? Because one of the limitation already you observed in the average values, right? So what could be the problem here? So here simply they are trying to arrange that elements in the form of triads, right? Group of 3 elements. All the elements could not be arranged in the form of triads. What the elements are available, that classification not enough to make a group of 3 elements by using all the available elements. So it is impossible to arrange the available elements in the form of triads. So this law failed for very low or very high mass elements. What is the law? Arranging the elements in the increasing order of atomic weights and observing that elements into the group, right, which can satisfy that average value of the first and last element atomic weight must be equal to the middle element. So that the law suggested. But in the table 1, I noticed that average values are different from the practical values. Right? So not applicable. Then here they don't know actually finding the atomic weights. Logically, they assumed, they predicted the atomic weights of the elements, right? So now the techniques are improved to find out the atomic mass or atomic weight simply. But if you compare these values, they are not giving you the values as they taken. So they are predicted, but not accurately. They are not valid strictly, right? So these we are saying guys, limitations for the Dauber-Inner law of triads. For example, chlorine, bromine, iodine is there. Chlorine, bromine, and iodine is there. So in that, atomic weights you observed, here average is not equal to the atomic weight of the middle element. So by taking like these examples, you are able to discuss about the limitations. You are able to discuss the limitations for the classification of Dauber-Inner law of triads. Right? So this is about today's class.